Okay, if I am looking at sequences and I'm asked for the 100th term, I'm going to have to write out all of the terms before it to figure out the 100th term. However, we can use what's called an explicit formula. You might never really see that word later on, but it's a formula that allows you to compute any term in the sequence without actually figuring out all 99 terms before you get to term 100. And so basically it just means that we're going to write an equation from our sequence. And so let's look at these. Example A. My sequence is 3, 5, 7, 9. Well, remember, in order to figure out what's happening, I either have to multiply or I have to add. So to get from 3 to 5, I could add 2. And then from 5 to 7, I can add 2. From 7 to 9, I would add 2. And so if I'm adding every time, remember that that is an arithmetic sequence. And the common difference is 2. Now when I make a table, remember we say that the position, like what spot is it in? So the first term was 3. I'm getting that from here. My second term is 5. My third term is 7. And my fourth term is 9. And so now that I have a table, I can use my answer choices and plug them into the calculator and see which one matches the table. So that's what we're going to do. So I'm going to go to my calculator and I need to go to a graph page. And where it says f of x, that's like your a sub n. So I'm just going to type letter A, which says 2x minus 1. You have to use x instead of n. And it gives me a line, and in order to see if the table matches, remember we press menu, 5 for trace and 1 for graph trace, and I can type in any x value I want. So the first value is 1, 1 goes to 1. So automatically answer A is out because 1 has to go to 3. All right, if I go change it, so if I press tab and I go up, I can change that equation to x plus 2. And then again, I do menu 5, 1, and 1 goes to 3. But now I need to check 2. 2 goes to 4. But on my table, 2 goes to 5, so letter B is also out. And then letter C, 2x plus 1. So let's go change it again. 2x plus 1. And if I do menu 5, 1, 2, well, let's just type in 1. 1 goes to 3. And then if I type in 2, enter, 2 goes to 5, and 3 goes to 7, and 4 goes to 9. So that makes letter C my answer. If you're paying attention though, this part, your common difference, is kind of like your slope. And so my slope had to be 2, which means this one won't work anyway. So now I know which equation it is. If I sketch a graph, I'm just drawing my x and my y-axis. And if I go back to my graph, I can see that on the graph, my y-intercept is 1. And so it needs to cross here at 1, and it's just a line going up. Okay. Find a of 12. Well, a sub 12 means that I would type in 12, enter, and my answer here is 25. So a sub 12 equals 25. So an arithmetic sequence creates a linear function. Let's write that out to the side. An arithmetic sequence creates a linear function. And again, the thing I really need you to understand is how we created this table, because if you can make the table, then you should be able to use your calculator to get the rest of the answers. All right, let's go look at example B. So here my sequence is 1, 6, 12, and 24, and it actually says a sub 1 is 3, which means that the first term is 3. A sub 2 is 6. A sub 3 is 12, and a sub 4 is 24. I'm paying attention to this part, or the y values, the term, to figure out the pattern. So from 3 to 6, I could add 3. But then if I add 3 to 6, I get 9, so I'm not adding every time. So from 3 to 6, I could also multiply by 2, which would give me 6. And 6 times 2 is 12, and 12 times 2 is 24. So that means this is a geometric sequence, and it has a common ratio of 2. And at this point, I do the same thing. I can plug these into the graph page and check the numbers. Now, at the very top of the paper, we put some formulas, and we're not going to go into total detail, but this is saying that if I have a geometric sequence, then it equals the first term times the common ratio to the n minus 1 power. Okay, n minus 1 meaning the term before. So if I know that it has to start with the first term, and my first term is 3, that should actually tell me my answer is C. My first term is 3. And then times the common ratio is 2. But let's type in letter A just to see what happens. So I'm going to go to my calculator. I'm going to add a new page. And again, we're going to use X instead of N. So letter A says 2, parentheses 3. And then to get to the exponent, you press this button right here, the one that's red now, to the X minus 1. And then I press enter. And it gives me a graph that looks like a curve. If I press menu 5-1 and I push 1, 1 sends me to 2, which means that A is not my answer. I could type in B, but I'm going to tell you that that's also not my answer based on the fact that we looked at the top here and we know that we're multiplying. So I know B is not going to be my answer. And so let's type in C. So I'm just going to add a new graph page here. C says 3 times 2 exponent key X minus 1. And I have to do the menu 5-1. And if I type 1, I get 3. If I type 2, I get 6. 3 gives me 12, and 4 gives me 24. So I'm going to go back to the beginning here. And I can see that it's a curve. So I know that my answer is C. I'm going to sketch a graph again. And it looks like this. It's a curve going up. And this is actually an exponential function, which we talked about a little tiny bit at the beginning of the year. Okay, exponential function makes a curved line or a curved graph. And then it says find A of 12. So that means I go back here and I just type in 12. And it's actually not going to give me what exactly I want. So I could look at my table, Control T, and just find 12, which A of 12 is 6,144. Okay. So at the moment we've talked about the two different types of sequences and what they would look like as equations that would let us find any number in that sequence.